All right, everyone, get ready to dive deep into some seriously cool science. We're talking about those amazing, mind-blowing facts that make you go, wait, what? Really? We've got a whole bunch of them lined up for you today, covering everything from space to the human body. It's like a crash course in all the awesome stuff science has uncovered, but without the, complicated jargon and textbooks.
Exactly. We've got this massive collection of stuff from all sorts of sources, and it's just wild. Space, the human body, physics, chemistry, technology, you name it. And it's all designed to spark that little aha moment in your brain, where you just go, wow, I had no idea.
So to kick things off, let's zoom out to space for a second. And I mean, really zoom out. Ever heard of neutron stars? They're like the leftover bits of giant stars that have gone supernova, a spectacular explosion that marks the end of a star's life, basically. But here's the crazy part. If you could somehow take a tiny little piece of a neutron star, like the size of a sugar cube, and bring it back to Earth, it would weigh 1 billion tons.
1 billion tons just from a sugar cube size piece. That's insane.
I know, right? It's because all the stuff that makes up a neutron star is packed together so incredibly tightly.
Well, it all comes down to gravity, really. You see, in a normal atom, you've got all this space between the tiny nucleus in the center and the electrons buzzing around it. But in a neutron star, gravity is so strong it basically crushes everything together. Protons and electrons combine to form neutrons, and that's why they're so incredibly dense.
Okay, mind officially blown. Now let's talk about something a little closer to home, well, sort of. Our solar system. Specifically, some of the weird stuff that's going on with days and years on other planets. Did you know that on Venus, a day is actually longer than a year? It's totally backwards.
It's crazy, right? Venus takes about 243 Earth days to spin once on its axis, which is what we call a day. But it only takes 225 Earth days to go all the way around the sun, which is a year. So yeah, a day on Venus is longer than a year on Venus. Talk about a long day at work.
Right. And Mercury's got its own weirdness going on. It's got this really slow spin, so a day on Mercury lasts about 59 Earth days, but it zips around the sun super fast, so its year is only 88 Earth days long.
Yeah, the planets have some pretty wild rotations, it's true. And a lot of that has to do with, well, how they formed and what happened to them billions of years ago. Like, early collisions with other objects can really mess with the planet's spin.
Yeah.
And then there are the tidal forces from the sun, sort of like how the moon's gravity affects our tides here on Earth. Those forces can really slow down a planet's rotation over time.
It makes you appreciate our good old 24-hour day and 365-day year, that's for sure. Now let's talk about the big guy in our solar system, the sun. It's absolutely massive, right? I mean, we all know it's big, but just how big is it, really?
The sun accounts for a whopping 99.86% of all the mass in our entire solar system. Seriously, all the planets, the moons, the asteroids, everything, they all add up to a tiny fraction compared to the sun.
Well, that's kind of humbling.
It is. It's also what keeps us all in check, gravitationally speaking. The sun's gravity is what holds all the planets in their orbits. It's kind of like a giant cosmic anchor, keeping everything from flying off into the vastness of space.
Okay, so we've got this massive sun, but it's just one star, right? And there are a lot of stars out there, like a lot.
Oh, there are more stars in the observable universe than there are grains of sand on all the beaches on Earth. Imagine that every single grain of sand on every beach, and then multiply that by, well, an unimaginable number.
That's mind-boggling.
It really puts things into perspective, doesn't it? And think about this. Each of those stars could have its own planets, its own solar system. So there can be countless worlds out there, some maybe even like ours with life. Who knows?
Some of those stars, when they die, don't just fade away. They collapse in on themselves and become these things called black holes. And black holes are just, well, weird. I mean, their gravity is so strong that nothing, not even light, can escape them.
Right, and that's where things get really interesting. We're talking about physics at the extreme, where our understanding of how the universe works really gets tested. For example, some black holes spin incredibly fast, close to the speed of light.
The speed of light.
Yep, almost. And that just throws all sorts of crazy physics into the mix, like how does space-time behave around a spinning black hole? What happens at the edge of a black hole, the event horizon? These are questions that scientists are still trying to figure out.
All right, well, let's think about something a little less mind-bending for a second. Our own galaxy, the Milky Way, it's pretty big, right?
Yeah.
But did you know it's actually on a collision course with another galaxy, Andromeda?
Yeah, in about 4 billion years, give or take, These two giant spiral galaxies are going to slam into each other.
Slam into each other.
Well, it's more of a slow dance, really. They'll kind of merge together, gravity will pull them closer and closer, and eventually they'll form one giant elliptical galaxy.
So mark your calendars for about 4 billion years from now, I guess.
Uh-huh, right. But in all seriousness, it's a fascinating process, and it shows that even on a galactic scale, the universe is constantly changing and evolving.
Okay, one last space fact for now.
Yeah.
Ever wondered why they say silent as space? Well, it's not just a saying, it's actually true.
Yep, space is a vacuum. That means there's practically no air or any other stuff for sound waves to travel through. So all those epic explosions and spaceship battles you see in movies, they wouldn't actually make any sound in real space.
So it'd be a pretty quiet place to be, even with all that crazy stuff going on.
Definitely, it'd be a very different sensory experience than what we're used to here on Earth.
Okay, let's shift gears now and talk about something a little closer to home, literally, the human body. We're all walking around in these amazing biological machines, but we rarely stop to think about all the incredible stuff happening inside us.
Right, and one of the most fundamental things about us is our DNA, the genetic code that makes us who we are. But here's the wild part. Your DNA is actually 99.9% identical to every other person on the planet.
Wait, really?
Yep, it's that tiny 0.1% difference that accounts for all the amazing variation we see in humanity, like eye color, height, all those things that make us unique.
So we're all basically 99.9% the same. That's kind of mind-blowing.
It is. And think about it. That tiny fraction of difference is what gives us all the different talents, personalities, everything that makes us who we are as individuals. It's pretty remarkable.
Now let's talk about our brains for a second. They're pretty amazing organs, and they're working hard all the time, even when we're not really aware of it. In fact, our brains actually use a lot of energy.
Oh, yeah. The brain is a real energy hog. It accounts for about 20% of our body's total energy use, even though it only makes up about 2% of our body weight.
20%? That's crazy.
I know, right? It's because your brain is constantly active even when you're sleeping. It's processing information, controlling your bodily functions, forming memories, all sorts of stuff.
Well, it's really working hard for me right now, trying to wrap my head around all these crazy facts.
Haha, same here. But that's the fun of it, right? Learning new stuff, expanding our understanding of the universe and ourselves.
Absolutely. Now, here's a fact that might make you feel a little less like a singular entity. It turns out that you're actually carrying around more bacterial cells than you have human cells in your body.
Yep, that's right. We're more microbe than human, in a way. But don't worry, most of these bacteria are good for us. They help us digest food, boost our immune system, and even play a role in our mood. We have a kind of symbiotic relationship with them. They get a place to live, and we get all these benefits in return.
So we're like walking ecosystems, basically.
Pretty much. And it just goes to show how interconnected everything is, even at the microscopic level.
Okay, let's talk about something a little less microscopic now. Have you ever thought about how different animals have evolved some pretty amazing adaptations? Like take octopuses, for example.
Oh, octopuses are amazing creatures. They're super intelligent. They can change color and texture to blend in with their surroundings. And get this, they have 3 hearts.
3 hearts.
Yep, 3. 2 of them pump blood through their gills, which is where they get oxygen, and the 3rd heart circulates the oxygenated blood to the rest of their body. It's a really efficient system.
Wow, nature's just full of surprises. Now, here's a fact that puts things in perspective. Sharks have been around for a lot longer than trees. I mean, a lot longer.
Oh yeah, sharks are ancient. They've been swimming in the oceans for over 400 million years. Trees, on the other hand, only appeared on land about 350 million years ago. So sharks were already cruising around long before the first forests even existed.
That's kind of hard to imagine. Speaking of amazing adaptations, our own stomachs have a pretty impressive trick up their sleeve. Did you know that your stomach lining actually renews itself every 3 to 4 days?
It has to. The stomach is a harsh environment full of acids that break down food, so the cells lining the stomach are constantly being replaced to protect the stomach itself from being digested. It's a pretty efficient system.
Okay, this next one is mind-boggling when you think about the scale of it. If you could unwind all the DNA in a single human cell and lay it end to end, it would be about 2 meters long.
I know, it's crazy, right? All that genetic information, the entire blueprint for a human being packed into something so tiny we can't even see it without a microscope. And it's all organized in this incredibly intricate way, coiled and folded up to fit inside the cell's nucleus.
And that's just one cell. We have trillions of cells in our bodies. Now, here's one that sounds like something out of science fiction, but it's totally true. A human heart can actually continue to beat even if it's removed from the body, as long as it has a supply of oxygen.
It's true. The heart has its own internal electrical system that keeps it beating, so it can keep going for a while even when it's not connected to the rest of the body. Of course, it needs oxygen and nutrients to keep functioning, but it's a testament to the heart's incredible resilience.
Okay, let's talk about something a little less intense. Hair. We all lose hair every day, right?
Mm.
But did you know it's totally normal to lose anywhere from 50 to 100 hairs per day?
Yep, that's just part of the natural hair growth cycle. Each hair follicle goes through phases of growth, rest, and shedding. So when you see a few hairs in your brush or in the shower drain, don't panic. It's perfectly normal.
All right, and last but not least, in our human body deep dive, let's talk about our sense of smell. It's often overlooked, but it's incredibly powerful. Did you know that the human nose can detect over 1 trillion different scents?
That's right. Our sense of smell is actually much more sensitive than our sense of taste. And we have all these different types of odor receptors in our noses, each one tuned to detect specific molecules. It's this complex interplay of signals that allows us to distinguish between such a vast array of smells.
Okay, we've covered a lot of ground already, from the vastness of space to the intricacies of the human body. But now let's dive into a whole different realm, the world of physics and chemistry. And we're going to start with something that seems really counterintuitive. Atoms, the building blocks of everything around us, are mostly empty space.
It's true. If you could somehow remove all the empty space from all the atoms and every person on Earth, the entire human race could fit into a space the size of a sugar cube.
Wait, what? That's
I
insane.
know, right? But here's the thing. Most of an atom's mass is concentrated in this tiny nucleus at the center, which contains protons and neutrons. The electrons, which are negatively charged, are whizzing around the nucleus at a relatively enormous distance. It's this electromagnetic force between the positively charged nucleus and the negatively charged electrons that creates the illusion of solid matter.
So we're basically walking around in a sea of mostly empty space.
Pretty much. And it just goes to show that reality is often much stranger than it appears.
Okay, speaking of things that are hard to wrap your head around, think about the sunlight that's hitting us right now. It takes about 8 minutes for that light to travel from the sun to the earth.
Yep, that's right. So when you look up at the sun, you're actually seeing it as it was 8 minutes ago.
Whoa, that's trippy.
It is, and it highlights the vast distances involved in space. Even light, which travels incredibly fast, takes time to cover those distances.
Now let's talk about an element we're all familiar with, helium. It's the gas that makes balloons float. But did you know it's also the only element that can't be frozen solid at normal atmospheric pressure?
It's true, you can cool helium down to incredibly low temperatures, but it won't freeze solid. It's because the atoms of helium are so small and weakly attracted to each other that they just can't form a rigid structure like a solid.
Huh, that's pretty cool. Speaking of cool, water is pretty amazing stuff, right? I mean, it's everywhere. It's essential for life. And it's the only substance on Earth that naturally exists in all 3 states: solid, ice, liquid, water, and gas, steam, within the normal range of temperatures we experience.
Yep, water is truly remarkable, and it's those unique properties of water that make it so essential for life.
Okay, time for a little myth busting. I'm sure you've heard that diamonds are indestructible, right? Well, guess what? They're not. In fact, diamonds can burn.
It's true. Diamonds are made of pure carbon, just like the graphite in your pencil, and carbon can burn. So, if you heat a diamond up to a high enough temperature in the presence of oxygen, it'll go up in flames.
Wow. So much for being forever. Okay, back to some mind-blowing physics. The speed of light,
Yeah.
it's the fastest speed anything can travel in the universe, right? But just how fast is it really?
It's about 299,792 kilometers per second, which is about 186,282 miles per second. It's almost impossible to imagine something moving that fast.
Yeah, my brain is starting to hurt just thinking about it.
Mine too. But that's the beauty of science, right? It constantly challenges us to think beyond our everyday experiences and grasp the truly amazing nature of the universe.
Now, remember those neutron stars we talked about earlier? Those incredibly dense remnants of collapsed stars? Well, let's try another comparison to illustrate just how dense they are. If you could somehow scoop up a teaspoonful of material from a neutron star, it would weigh about 6 billion tons.
It's mind-boggling, right? And it all comes down to the immense gravitational forces at play within a neutron star, crushing all that matter into an incredibly compact state.
All right, let's talk about temperature extremes for a minute. The coldest possible temperature in the universe is something called absolute zero. It's negative 273.15 degrees Celsius, or negative 459.67 degrees Fahrenheit.
At absolute zero, all molecular motion stops completely. It's the theoretical point where everything freezes solid, even atoms themselves. Of course, reaching absolute zero is practically impossible, but scientists have gotten incredibly close in laboratory settings.
So pretty much the ultimate cold snap.
Exactly. And it allows scientists to study some really weird quantum effects that happen at these extremely low temperatures.
Okay, here's a fact that might change how you think about something we encounter every day. Glass. That seemingly solid material in your windows is actually considered to be a very, very slow-moving liquid.
It's true. Over very long periods, like centuries, glass can actually flow slightly under its own weight. You might have seen this in old buildings with stained glass windows, where the glass at the bottom is a little thicker than at the top. It's subtle, but it's happening.
Wow, that's wild. Okay, one last physics fact for now. Have you ever noticed that things tend to expand when they get hot? Like the gaps in sidewalks get wider in the summer, or metal bridges can sag a bit. Well, that's because of something called thermal expansion.
Right, thermal expansion is just the tendency of matter to change in volume in response to temperature changes. When things heat up, the molecules move around more and they need more space, so the material expands. And when things cool down, the molecules slow down and the material contracts. It's a pretty fundamental principle of physics.
And it can have a pretty noticeable effect on large structures like buildings and bridges.
Oh, absolutely. Engineers have to take thermal expansion into account when designing these structures to make sure they don't buckle or break under extreme temperature changes.
Okay, let's shift our focus now to our home planet, Earth, and all the incredible natural wonders it holds. And we're going to start by debunking a common myth about where our oxygen comes from. Many people think that trees are the main source of oxygen, but actually, it's the ocean.
That's right. Tiny marine plants called phytoplankton produce the majority of the oxygen we breathe. They live in the upper layers of the ocean and use photosynthesis to convert sunlight into energy, just like plants on land. And because the ocean covers such a huge portion of our planet, the sheer number of these phytoplankton means they produce a lot of oxygen.
So we can thank the ocean for every breath we take.
Pretty much. Of course, trees are still important. They absorb carbon dioxide and release oxygen. But when it comes to the overall oxygen production on Earth, the ocean is the real MVP.
Now, while the ocean might be the biggest oxygen producer, the Amazon rainforest is still a vital part of our planet's ecosystem. It's responsible for about 20% of the world's oxygen and plays a crucial role in regulating the Earth's climate.
The Amazon is often called the lungs of the planet for a reason. It's a massive carbon sink, which means it absorbs huge amounts of carbon dioxide from the atmosphere, helping to mitigate climate change.
Okay, here's a geographical fact that might surprise you. Antarctica, the continent covered in ice and snow, is actually classified as a desert.
It's true. It might seem counterintuitive, but a desert is defined by its lack of precipitation, not necessarily its temperature. And Antarctica receives very little precipitation, less than the Sahara Desert in some areas.
Wow, that's wild. So you've got this massive continent covered in ice, but it's technically a desert. Speaking of massive, the Great Barrier Reef off the coast of Australia is the largest living structure on Earth.
It's truly an incredible sight. It's made up of billions of tiny coral polyps, these little animals that build calcium carbonate skeletons. And over thousands of years, these skeletons have accumulated to form this vast, intricate reef system that stretches for over 2,300 kilometers.
2,300 kilometers, that's huge.
It is, and it's so big that you can actually see it from space. It's a testament to the power of nature and the incredible things that can be created over time.
All right, let's go deep now, really deep, to the center of our planet. At the Earth's core, temperatures reach a scorching 5,500 degrees Celsius. That's as hot as the surface of the sun.
It is incredibly hot down there. That heat comes from a couple of sources. The leftover heat from when the Earth formed billions of years ago, and the decay of radioactive elements within the Earth's interior. And that heat is what drives a lot of the geological processes on our planet, like plate tectonics and volcanic activity.
So the Earth is kind of like a giant molten engine.
In a way, yes, and all that heat and energy are what make Earth such a dynamic and geologically active planet.
Okay, now, let's think about all the life that exists on Earth. We tend to focus on the big stuff, the plants and animals we can see. But did you know that there are more microorganisms living in a single teaspoon of soil than there are people on the entire planet?
It's true. The soil is teeming with microscopic life, bacteria, fungi, all sorts of things, and they play a vital role in breaking down organic matter, recycling nutrients, and keeping the soil healthy. They're the unsung heroes of our ecosystems.
So we're walking on top of a whole world we can't even see.
Exactly. And it's a world that's essential for all life on Earth.
Okay, let's talk about something a little more dramatic. Lightning. It's a pretty awesome display of nature's power,
Yeah.
right? But did you know that lightning strikes the Earth about 100 times every second?
That's right. It's a constant barrage of electrical energy, and it plays an important role in atmospheric chemistry. It helps convert nitrogen in the air into a form that plants can use.
So lightning is actually good for plants.
It is. Of course, it can also be dangerous, but it's a fascinating natural phenomenon.
Now, let's go to the opposite extreme, the deepest part of the ocean. The Mariana Trench in the Pacific Ocean plunges down to an incredible depth of 11 kilometers, or 7 miles. That's deeper than Mount Everest is tall.
It's a truly alien environment down there, with immense pressure and perpetual darkness. But even in this extreme environment, life finds a way. There are all sorts of bizarre and fascinating creatures that have adapted to survive at these incredible depths.
Wow, that's amazing. So we've got life thriving in the hottest parts of our planet and in the deepest, darkest parts of the ocean. Pretty incredible.
It is. It really shows how resilient and adaptable life is.
Okay, one last Earth fact for now. Did you know that Earth's magnetic field is actually weakening? It's not going to disappear overnight, but it's something scientists are keeping a close eye on.
The Earth's magnetic field acts like a shield, protecting us from harmful radiation from the sun. And it's generated by the movement of molten iron in the Earth's core. But for reasons scientists are still trying to fully understand, that magnetic field is gradually weakening. It's a natural process, but it could have implications for our planet and our technology in the future.
Okay, let's switch gears one last time and explore the ever-evolving world of technology and innovation. And we'll start with a little bit of computer history. The first computer virus, believe it or not, was created back in 1983. It was called Elk Cloner.
Elk Cloner was relatively harmless. It was more of a prank than a malicious virus. It was designed to infect Apple II computers and display a little poem on the screen. But it was a significant milestone in the history of computing because it was the first known example of self-replicating code that could spread between computers.
So the first computer virus was basically a digital prank.
Pretty much. It's a far cry from the sophisticated malware we see today, but it was a sign of things to come.
Now, here's a fact that might make you think twice about all those Google searches you do every day. A single Google search uses as much energy as it takes to power a 60-watt light bulb for 17 seconds.
It might not seem like a lot, but when you consider the billions of Google searches happening every day, the energy consumption adds up quickly. All those servers and data centers require a lot of electricity to keep running.
So maybe we should be a little more mindful of our Googling habits.
Maybe so, or at least make sure we're using energy-efficient devices and search engines that are committed to sustainability.
Now, here's a fun fact about the internet as a whole. All those servers, cables, routers, all the data stored online, it all weighs about the same as a strawberry.
I know, it's crazy, right? About 50 grams. It just shows that information itself doesn't have much mass, but the infrastructure that supports it, the physical hardware, that's what adds up.
Okay, let's talk about the future of computing for a minute.
Yeah.
Quantum computers are all the rage these days, and for good reason. They have the potential to revolutionize everything from medicine to material science.
Quantum computers are still in their early stages of development, but they're incredibly powerful. They use the principles of quantum mechanics to perform calculations in ways that classical computers can't. And this allows them to tackle problems that are currently intractable for even the most powerful supercomputers.
Oh, they're basically superpowered computers.
Exactly. And they have the potential to unlock some incredible breakthroughs in the future.
Okay, let's take a quick trip down memory lane in mobile technology. The first camera phone was invented in 1997, and it had a resolution of just 0.11 megapixels. Compare that to the multi-megapixel cameras we all have in our smartphones today.
It's amazing how far camera phone technology has come in such a short time. That first camera phone was a real game changer, though. It opened up a whole new world of possibilities for mobile photography.
And selfies, of course.
Of course.
Okay, here's a comparison that illustrates the incredible complexity of modern technology. A modern self-driving car uses more lines of code in its software than the entire operating system of a Boeing 787 Dreamliner.
That's right. Self-driving cars are incredibly complex machines. They have to be able to perceive their surroundings, make decisions in real time, and control the car safely. And all of that requires a lot of code.
So maybe we shouldn't be surprised when they make mistakes.
Well, the technology is still evolving, but it's come a long way in a short amount of time, and it has the potential to revolutionize transportation in the future.
Okay, one last tech fact for now.
Yeah.
The first website ever created went live in 1991, and believe it or not, it's still online today. You can actually visit it at http://info.cern.ch.
It's a fascinating glimpse into the early days of the internet. It's a very simple website, just text and links, but it was groundbreaking at the time. It helped to lay the foundation for the World Wide Web as we know it today.
All right, that was a whirlwind tour through some of the most amazing and mind-blowing science facts out there. We've covered everything from the vastness of space to the intricacies of the human body, from the fundamental laws of physics to the cutting edge of technology.
It's been an incredible journey, and hopefully it sparked some curiosity in our listeners. There's so much more to learn and discover about the universe and ourselves, and the more we learn, the more we realize how much we don't know.
Exactly. So as you go about your day, keep your eyes open, have questions, and never stop exploring the wonders of science. Because the universe is full of amazing things just waiting to be discovered.